All right, so you have a test coming up on Friday, and you will get to use your study guide on the test. You will get to use calculators on the test. If you need a ruler or something like that, you can use that as well. I don't know that you'll need one, but this study guide will look very similar to what the test looks like. Same types of questions, same progression through the test and everything. Of course, just for the most part, the numbers and details of the questions are different. So here we go. Question 1, if a function has an input of 2 and an output of 15, which of the following could be the function rule? And we must choose all that apply. So it could be more than one answer, could be all of them, could be just one of them, but here we go. So we want to know if we have an input of 2 and an output of 15, what can I do to that 2 to get 15? So what do you got? Daniel?
Plus 13.
Plus 13, okay. So it could be we take the input and add 13 to it. Okay, is that one of my options? Okay, so C says double the input, then add 13. So if I did double the input, that's 2 times 2 plus 13, 13. That would be 4 plus 13 equals 17. So that C actually does not work because we can't double the input and then add 13 to make that one work. Okay? How about add 20 to the input, then add 7?
No.
Okay, that'd be 22 plus 7 would be 29. That doesn't work. B, okay, let's try B. So multiply the input by 5. 2 times 5 plus 5. So if we take our input, multiply by 5, that's 10. Plus 5 would be 15. That works. Okay, so B works. And then what about this one? Multiply the input by 8, then subtract 1.
No.
Well, if the input is 2,
Yeah.
2 times 8 is 16. Then subtract 1, that's 15. So that would be 2 times, times 8 minus 1 equals 15. That one works. Okay, so A and B are both true. Could possibly be the input rules, okay? All right, given the input rule below, complete the table. So we have our input is 3. We have a rule, which is times negative 3, then add 10. And it gives us an output. So if I take 3 times negative 3, that would be 3 times negative 3. That's negative 9 plus 10 equals 1. Does that make sense? So that's how our input rule works. We've already got our input and an output filled in here. So all I need to do is complete the table. So if my input changes to 5, that would be 5 times negative 3 plus 10. So 5 times negative 3 is negative 15 plus 10. That would be negative 5. Okay? And then I change my input to 7. So 7 times negative 3 plus 10. What's 7 times negative 3? Negative 21 plus 10. Negative 11. And you guys, of course, can use your calculators. Once you have this written down, all you would have to do is type it straight in. 7 times negative 3 plus 10 equals, and it'll tell you what the output is. Okay, and then our last one would be 10 times negative 3, which is negative 30, plus 10 is negative 20. Okay, so there we go. That completes the table. That's all we have to do on that one. This one, sketch a graph, and I'm not giving you a graph. Just like on the study guide here, on the test you have a blank space. So you're going to have to create your own graph. It says sketch a graph to represent the story below. Be sure to label the axes of the graph appropriately and write a function statement for the story. Okay, so we know we're going to have a graph, so I can just do this just to start, right? And it says Jessie kept track of her distance traveled during a car ride. Okay, so distance traveled, and then what's our other variable gonna be? So we've got distance, and we've got, it took her 1 hour to travel the first 30 miles. Where does that, how are we gonna graph that? Which is gonna go on the X, which is gonna go on the Y?
Miles go on the x-axis.
What do we always want on the X-axis?
Yeah,
We always, what is it that we always like to have on the X-axis? Time. So we're gonna put hours on the X-axis. Or you can put time, either way is fine. Okay, but we always want time to be on the X-axis. And then what do we want to be on the Y-axis? Distance or miles. Either one of those is fine, miles or distance. Okay? All right. So it seems to be that we're going by, 1 hour to travel the first 30 miles, then the next hour, and then 1 hour. So let's make some 1 hour increments here. And we don't want to make them too tight together. We want to give ourselves some nice space here, right? 1, 2, 3. If we did them all scrunched up here, that would make our graph real hard to read and real hard to make. So we know we're going to need 3 hours. And it says it took her 1 hour to travel the first 30 miles. And so we can make our increments in, I don't know, 10 or 20 mile, let's do 20 mile increments. 20, 40, 60, 80, 100, 10, 20, 20, 40, 60. So I think that should be good. So if we number those 20, 40, 60, 80, 100, 120, 140, 160. Okay? So it took her 1 hour to travel the first 30 miles. So at 1 hour, we should be at about 30 miles. And then we'll fill in the lines here in a second. But then rush hour ended, she traveled 70 miles in the next hour. So how far do I need to get in the next hour?
To 70, to 100.
To 100, yeah. She's already at 30, so I need to get up to 100, which was right about there. And then the last hour, she drove the final 50 miles in 1 hour during a rainstorm, so she had to slow down a little bit. Okay? And so from 100, how far?
To 150.
To 150. Okay, so, right about there. So then we can put our ruler to it. And if you guys are using, freehand on the study guide, that's fine, but try to make your one on your test as accurate as possible. So we don't have a linear graph, do we? We've got, it's not a straight line. It's got different rates of change from one point to the next. Okay? Now, do we have a function? As we pass a vertical line across it, does it ever touch 2 points at once?
No.
Nope. So that makes it a function. It is a function, which means we can.
Mr. Fish,
Yes?
could I have Esme Hackney for the people?
Sure.
Thank you.
The video will be posted to Google Classroom, Esme, so you can finish the rest of the study guide. Okay. So we can write a function rule. We can write or not a function rule, but a function statement. So do you remember function statements? That's back from the first part of the chapter, or first part of the unit. Anybody remember how to make a function statement? It's real simple. Output is a function of input.
Y is independent of the
Well, y is dependent and x is independent, but what's on our y-axis? What's our output? Our output is miles. So output, miles, are a function of hours. Miles are a function of hours. So if I was writing notes on this, other than just having the problems here, I might, circle this up here and make something like output is a function of input. Y is a function of X or something like that, you know, might help you as well. Because it's going to be a little different scenario. It's not the same type of scenario. It's not driving and miles on the test. It's similar. I mean, a similar setup where you have to make a graph and draw the thing, but you're going to have to get your axes labeled and then use the X and the Y value to make your function statement. Miles are a function of hours. That's all you have to do. Does that make sense? Okay. All right, on your study guide and on the test, I'm leaving the formulas. You don't have to memorize the formulas, but you have to know how to use the formulas to find the volumes of cylinders, spheres, and cones. So what is the volume of a cylinder that has a radius of 11 centimeters and a height of 5 centimeters? Radius of 11 and height of 5, so
Plug in 11 for the radius.
11 for the radius and 5 for the h. So volume equals pi times radius is 11, 11 squared times 5 is the height. And guys, then you can just use your calculators. And here's the deal. Balt, what's your question?
Are we still going to use pi? Or?
I was just about to answer that question. I'm glad you asked it though. How about this? Your choice. If you want to multiply by pi and give a full answer with the decimal and everything, fine. If you want to leave pi out of it, I'm not specifying on the test or in the handout. If you want to leave pi as part of your answer, then just do 11 squared times 5 equals 605.
Pi.
So that would be 605 pi. Do not forget your labels, centimeters cubed. Or if you want to use the pi button, times pi equals 1900.7. 1900.7 centimeters cubed. I'm okay with either way. If you want to do the pi symbol or not do the pi symbol, that's fine. All right. So totally your call. All right, next, number 5, a sphere has a radius of 3.5 centimeters. What is its volume? So this, with a sphere, all we have to worry about is radius. We don't even have to worry about any other numbers. So volume equals 4/3 times pi times 3.5 cubed. Okay? You guys just coming in, I'm recording this right now because it's the test study guide, and I'm leaving early tomorrow, and some people aren't going to be here at all tomorrow because of the track meet, so this is going to be posted to Google Classroom for people who need to see the whole thing. So you have the study guides now, you're going to have the review online, the test is Friday. Okay? All right, so with your calculators, for ABC3 times 3.5 y to the x 3 equals 57.2 pi centimeters cubed. Or if you want to multiply, if you want to hit times pi, 179.6. I'm okay with either way. You guys coming in on the test and on the study guide, it doesn't specify to leave pi as part of your answer or to multiply it, so either way is fine. I don't care which way you do it. Ball.
Can we round it to the nearest tenth?
Round to the nearest tenth for sure, yeah. Okie dokie, this graph shows the temperature in Diego's house between noon and midnight one day. We just need to select all the true statements. You're going to see the same graph, it's just going to be different statements that you have to select. So time is a function of temperature. True or false?
False.
False, because temperature is a function of time. Okay, so that one is false. All right. The highest temperature occurred between 5 and 6.
False.
Okay, so between 5 and 6, that is definitely not the highest temperature. That would be false. The temperature was increasing from 8 to 9. That's false. The temperature was 70 degrees twice during the 12-hour period.
True.
All right, if we put that on there, 70 degrees at the beginning, and if you look straight across, it hits 70 degrees again right there.
Session 4 for Reality U, please report to the gym. Session 4 for Reality U, please report to the gym.
So that one's true. And then E, there was a 3-hour period during which the temperature decreased. Is there a, is there a,
From 9 to 11,
Yeah.
well, is that 3 hours?
9, 10, 11.
It's 2 hours.
If it's 9 o'clock now, how long does it take to get to 11?
2 hours.
That's a 2-hour period.
But if you count 9.
But you don't count 9. 9 is,
So it's false.
it's a false one. That one's false. Okay, so for this example, you have one true statement. When you, on the test, read through each individual statement, there may be more, there may be one, whatever. Okay? Number 7, for those of you that just came in, you will have the formulas will be given to you on the test. So don't worry about memorizing those. They're on the study guide. They are on the test. So you should be good to go. What is the volume of a cone with radius 12 centimeters and height 8 centimeters? All we have to do is plug numbers into the formula and let the calculators do the work. So volume equals pi times radius 12
12 squared,
times height
which is
over 3. Okay? So if I do 12 squared times 8 divided by 3, that's 384 pi centimeters cubed. And if you want to hit times the pi button on the calculator and do 1,206.4, that's okay too. 1,206.4 centimeters cubed. Okay. We good there? No? Okay, still writing. All right, so here is this question. Which has a greater volume, a sphere with radius 20 or a cylinder with radius 15 and height 47? So guess what we need to do? Find the volume of both of those and see which one is bigger. All right, there's no shortcut to it other than just doing the math and figuring it out. So if the volume formulas are listed on the previous page, so you can look back and see it if you need it. Radius of 20 for a sphere, we would have volume equals 4/3 times pi times 20 cubed. So 4/3 times 20 y to the x3, that's 1,666.7. 10,666.7 pi. So volume is 10,666.7 pi. And it doesn't give us a measurement. We don't know if we're in feet, centimeters, or meters, or what. Does that matter? No, it doesn't matter. They're both in the same unit, so we don't even need to stick a unit on it. Okay, so it's okay. And then we have the cylinder, volume equals pi times radius squared, 15 squared times 47. So 15 squared times 47 equals 10,575 pi. So what were we looking for?
Higher one.
The biggest one, which has the greater volume. So which one is it?
The sphere.
The sphere has the larger volume. Sphere is larger. Okay? Okay. This one's tricky. A cone and a cylinder have the same height and their bases are congruent circles. So the same height, same circle. Remember the experiment we did in class with the water? It's kind of like that. They had the same circle base and they had the same height. If the volume of the cylinder is 300 inches cubed, what is the volume of the cone, Braden?
100,
How'd you get that?
because, if a cylinder has the same height and like base as a cone, then 3, cones could fit another.
That's exactly what we showed with the experiment, right? 3 cones fit inside the cylinder when they're the same height and radius. So if we know the cylinder, all we have to do is cut that into 3 pieces, and that tells us the cone. So 300 over 3 equals 100 inches cubed, okay?
So that's like the,
All right? Oh boy, 3 students each calculated the volume of a cone with a radius of 6 centimeters and a height of 11 centimeters. Diego found the volume to be 132 pi centimeters cubed. Andre approximated 396 centimeters cubed. Noah rounded to 415 centimeters cubed. Do you agree with any of them, and explain your reasoning?
We have to find all of them.
We need to find the radius of the cone, or the volume of the cone. If we find the volume of the cone, we can check and see who's right and who's wrong, or if any of them are right or wrong, right? Okay, Ameline?
oh, I have the answer.
Okay, so let's set me up here. What'd you do?
So you just use the formula, so, 6, to the second power times 11 divided by 3.
Okay, so that's gonna give me the volume of the cone. So when you do, what number did you get?
I got, 132 pi centimeters cubed.
132 pi centimeters cubed. Okay, so we like Diego. So Diego,
But then if we wanna figure out if Andres or Noah's are right, we have to take 132 times pi.
okay, see, Diego is correct. And then, and then,
Noah is the closest.
okay, so 132 times pi is 414.7, which is, if we round that up, would be 415 centimeters, right? So no, we would also accept Noah's answer as well, right? So Noah, because it says that Noah rounded it, Noah is correct, okay. And I would just, you know how I do, guys. I would accept this as showing work that Diego is correct, and then if you showed volume equals 414, whoops, if you write it correctly, 414.7 centimeters cubed, I would accept that as showing that Noah is correct, because it's obvious that he rounded up, instead of rounding to the 10th, he rounded up to the nearest whole number, which is fine. Okay? All right. So, that is it. And guys, if you didn't hear when you came in, some of you came in a little bit later, the recording will be on Google Classroom, probably even later today, for you to be able to fill out the rest of your study guide. You are responsible for that. I will be here first part of the class tomorrow, but I'm leaving early for the high school track meet. And then I won't be here at all Friday. You've got a test Friday. Okay?